Hi, I'm Bob Adler, and I'm here to describe global precipitation means and variations with the new version of GPCP. You can see my co-authors up there. The GPCP is an observational-based blended analysis using satellite data over both ocean and land and gauge information over land. It's been around for a long time, and this is a new version. The new version has a number of key features and is available from the Goddard disk. It has finer spatial resolution, a half degree, updated satellite algorithms, including GPROF applied to SSMI and SSMIS, latest gauge analysis from GPCC, and ocean estimates adjusted using climatologies from TRMM, GPM, and CloudSat. The old version will be continued and will be compared to the new version in this talk. Looking at the climatologies from the new and old versions, are quite similar as seen in the top. The difference map does show some differences, primarily over oceans, with general increases there, with some decreases in drier zones. There are increases along the ITCZ, and the mid-latitude ocean maxima also increase. And there is a decrease along 60 South related to an artifact in version 2. The land and ocean zonal means are shown here, and the global totals are below. The global total land and ocean is now 2.8 millimeters per day. That's about 4.5% higher than version 2. Both the tropics and mid-latitudes are higher, and the southern hemisphere peak has shifted towards the equator, eliminating an artificial peak at 60 South in the older version. All this really happens over the ocean. As been seen here, you see much of the same thing. The oceans are now higher by 6%. Over land, there is very little change, and the land is lower by less than 1%. If you go to global totals and look at the whole time history in 1983 to 2019, you can see in general there is little or very small trend in the total global precipitation. The global anomalies are related to ENSO, that is, there are peaks during El Niños, and land and ocean anomalies partially compensate. However, even though the global total is really trendless, there are regional trends, as can be seen here with version 3 on the left and version 2 on the right. The version 3 trend pattern and magnitude are very close to the version 2 trends, although there are subtle differences that exist. But you can see increases in the ITCZ and Western Pacific, and decreases, for example, in the Southwest US. If you look at interannual variations in version 3 compared to version 2 over tropical oceans, this is 25 north to 25 south, one thing we've noticed, actually originally was picked out by Pete Robertson of NASA Marshall, is that the interannual variations in version 3 are larger, significantly larger than in version 2. And that is being driven by the new passive microwave algorithm that is used in GPCP, that is GPROF. And we're still looking at this, and the validity of this difference between version 2 and version 3 is being explored. So in conclusion, a new version of the GPCP Monthly Global Precipitation Analysis is now available from the Goddard disk. Version 3 has finer resolution, updated satellite algorithms, and uses TRMM, GPM, and CloudSat to adjust climatology. The ocean means are somewhat higher in the new version, mainly related to adjustments based on those satellites. The global mean total precipitation is now about 4.5% higher in this new version, with the oceans being about 7% higher. The trend map in the new version is very similar to that of the older version. This new version has come out within the last few months and still is ongoing, a lot of evaluation, and we are certainly interested in potential users' comments on this. Thank you.